we have a new relation here with 5 attributes A, B, C, D, E. And what are the functional dependencies of this relation? The functional dependencies are written here. A determines B, BC determines D, E determines C, and D determines A. So what can be the candidate key of this particular relation? So there can be many combinations of these 5 things. So which one of them is the candidate key? So how to find it? We will check all the things one by one. So no, this will be a time consuming method. I will teach you a shortcut. Okay, so learn this properly. So first we will check. There are 5 columns or 5 attributes A, B, C, D, E, and E. So first we will check which one of these is not on the right hand side of any functional dependency. Okay, so pause the video and repeat again. Whenever you are finding any difficulty to understand, pause the video and start from this part again and again. So we will do what? We will check which one of these 5 attributes is not on the right hand side of any functional dependency. Why we will check that? Because if a attribute is not on the right hand side of any particular functional dependency, then no other attribute can define this attribute. Okay, if the attribute is not on the right hand side of a functional dependency, that means no other attribute can define this attribute. So then this attribute must be the part of the candidate key. Why? Because we know that an attribute can define itself. So if no other attribute can define an attribute, then it must be a part of our candidate key. So suppose check here, B, D, C and A, these 4 are on the right side of any functional dependency, but E, the attribute E is not on the right side of any functional dependency. So whatever may be the candidate key or candidate keys, E must be a part of it. Okay, so first we will check the closure of E. Can E itself be a candidate key? Let's see. E can define E and E can define C. Okay, so see, that's the end of the closure of E. So this is not the candidate key. So now we will check with the combination with of E. So we will, let's suppose we will checking with AE. So we are checking the closure of AE. So what are the closure of AE? So let's see. A can define itself, E can define itself. Now check from the functional dependencies. A can also define B. Okay, cool. Now we have what? Okay, see, E can define C, A can define B, and E can define what? E can define C, and BC we have now. So BC together can define D. So this is the transitive property we are using. So BC can also define D. So we have all the 5 attributes here. So AE is our candidate key. Okay, so always remember that there can always be more than one candidate key. So never stop checking after finding just one candidate key. Okay, search for others also. So I will be writing our set of candidate key here. So we have one set, that is AE. So now let's check for others. So now what we can check? We can also try for all the other combinations of E. So but this will also be time consuming. So now again we will learning a trick to save our time. So see, what is the trick? Now let's check. If A or E, there are 2 parts of our candidate key, A and E. So if A and E are part of the right hand side of any functional dependency. So let's see, is A or E part of any functional dependency's right hand side? So E is not there, but see here, this functional dependency has A on the right side. That means what? That means D can determine A. Okay, so if D can determine A, then we can replace A with D in our candidate key. So our candidate key was AE, and if we can replace A with D, then our new key will be DE. So let's check its closure and confirm it. The closure of DE will be what? It will always be D can determine D, E can determine E, and E can also determine C, D can determine A, and again A can also determine B. So see, this is also our candidate key. So this will also be included into our set of candidate keys. Now again we will repeat the similar process. If D or E is present on the right hand side of any functional dependency, so let's see. So here, see here, D is present on the right hand side. D, this is D. D is present on the right hand side of this functional dependency. So which can determine D, B and C. Okay, so there are two more options we have, that is BE and CE. So what we have done, we are replacing D with B and C. Okay, we are replacing D with B and C. So for here, these two are together determining D. So we have written two more possible candidate keys. So we will check if they are actually the candidate key or not. So at least one of them will be a candidate key for sure. So let's check. So what is the closure of BE? So B can determine B, B can determine E, and E can determine C. BC can together determine D, and D can determine A. So BE star is a candidate key. So this is the candidate key also. Oh sorry, we are checking for one more. So now what we have C and E. So what so let's check its closure. So for C can determine C, E can determine E, and bus there are no more attributes which can be determined by this C closure. Okay, so this C is not a candidate key. So now let's see check if B is on the right hand side of any other candidate key. So see here, B is on the right hand side of this particular functional dependency. So A can determine B. So then we will do what? We will replace B with A. So if we replace B with A, it will again become what? It will again become AE. So we have already written AE inside our candidate key. So now it is becoming a loop. So now we can end this. Okay. So this is our set of candidate keys. We have 3 candidate keys for our this particular relation. So this is the shortcut way to find the candidate keys. So now we will check what are the prime attributes and non-prime attributes. So prime attributes are what? So let's see. A, E, D, B. These 4 are the prime attributes. And what are the non-prime attributes? The non-prime attributes are only C, as it is not part of any of the candidate keys.